Ooh, we're going to use the famous notation on this problem here. This literally just means do the same thing that we've done in the previous 7 problems. This is now the integral of this function. It's the same as an antiderivative. And this dx just tells us what variable we're integrating with respect to, similar to the dx that we used for derivatives. We'll talk more about this notation later. But first, we need to think, what function could we take a derivative of to get this answer here? And I don't think it's obvious, so I think we need to do a little bit of algebra. I'm going to keep the same notation here. We can split up this numerator into 2 pieces, and we can find the integral or the antiderivative of this. Now, a little bit of simplification. I'm going to call this 0.5 a 1/2. The x to the 7ths cancel. I'm going to call this 4.5 a 9/2. And I'm going to call this x to the 7th in the denominator and x to the negative 7th. And we're going to find the antiderivative of that, or the integral of that, with respect to x. And you'll recall that the derivative of this function here, 1 over n plus 1 times x to the n plus 1, is just x to the n. Now, using our new notation, we can write this a slightly different way. We can say that the antiderivative, or the integral, with respect to x of x to the n is 1 over n plus 1, x to the n plus 1. And now we're doing the same process that we did in some of our previous videos. Let's take a look at this term right here. If we want the integral, or if we want to integrate 9/2 x to the negative 7, what we're going to do is we're just going to keep that 9/2 there. We're going to raise the power on x by 1 according to this rule here. Negative 7 plus 1 is negative 6, and we're going to divide by that same number. Okay, great. That's going to give us the integral of that term right there. What about the integral of 1/2? The derivative of what function is 1/2? And if you think about it for a minute, you will remember that the derivative of 1/2 x is 1/2. Okay, so we've integrated both of these terms. Don't forget we need a plus c at the end. Now let's do just a little bit of simplification. Okay, this looks like a pretty good answer, but we should probably check it. If we take the derivative of this function right here, we should get back the original function. So let's see, the derivative of 1/2 x is just 1/2. If we take the derivative of this term, we have to multiply it by a negative 6. It's going to turn this minus into a plus, and we're going to get 18/4 x to the negative 7th. Derivative of a constant is 0. This 18/4 simplifies to 9/2. And that gets us back to this step right here. And if we reverse our algebra, we should get back to the original problem. Okay, so I think we did it right. Good job.